grade 12 physics, you are supposed to have an appreciation for simple harmonic motion in spring systems and how that relates to circular motion. Overall, this might be beyond the scope of this course to nicely explain and appreciate, but we will go over it here. And so you'll notice that when you hang a mass from a spring, now you can just, so this is the equilibrium of the position of the spring without the mass. We can find the equilibrium position of the spring with the mass, and so the spring has stretched until basically the force, the restoring force of the spring, is equal to the force of gravity on this mass. Now if we are to push this up, say to the equilibrium position, or even up into this position where the compression of the spring is going to provide downwards force in addition to gravity, we are going to set the conditions for simple harmonic motion. And so as you can see in this position, the force is overwhelmingly going to send this mass downwards. So there it goes. Okay, now the mass is undergoing simple harmonic motion. And so in a position like this, the mass is traveling downward. Gravity is greater than the spring force, and so this will be accelerating downwards in a position down here. Down here, on the other hand, the extension of the spring has exceeded what is the normal equilibrium position, and so if the spring is traveling downwards at this point, it's going to be slowing down in the downwards direction, or in other words, it's going to be accelerating upwards until it stops. At the point at which it stops, there is an upwards force on the mass, and the system will accelerate upwards, or at least continue to accelerate upwards. It will pass through the equilibrium position with a velocity, and then the acceleration will start downwards, slowing the spring down until such point as velocity equals 0, and it will continue to accelerate downwards. This time the velocity will also be downwards, and it will repeat the cycle over and over again. So there we go. There's simple harmonic motion.